Hey guys, welcome to a brief little video on some chemicals called hydrates. Now, what in the world is a hydrate? Well, it's just a chemical that includes water in the formula. And water isn't really part of the compound, but we have waters attached. So if you can imagine, I've got this substance right here. Oops, there we go. This substance right here, and it's an ionic compound, and what it does is it has some waters just attached to it. Anywhere from 2 to maybe, I think I've seen some as many as 8, but I'm sure there are more out there. But just imagine you've got this ionic compound, you've got some waters attached. We've got an example right here of cobalt chloride hexahydrate. Okay, there's its formula, and it's all nice and red. And then what we do is we heat it up, and once you heat it up, it turns blue. And now you have the anhydrous cobalt chloride. And anhydrous, the prefix an means not, so that means no waters. And so what we're going to do is we're going to use this chemical to help us figure out an empirical formula of a hydrate during a lab. And we've been spending some time with some empirical formulas, so it's going to be kind of a neat lab. So let's just talk about this. You can see I'm trying to go through these numbers. Okay, one of the things about hydrates, when we figure out the number of waters, we just write a dot, all right, like a time sign in algebra, and then you put however many hydrates there are. And the way we're going to name this is we're going to go ahead and say, and this would be called tetrahydrate because 4, as you guys know, means tetra. And so what we're going to do is let me just go over some typical questions you might see. Suppose you heard the word trihydrate. How many hydrates? Pardon me. How many waters would that be? Well, you would go, duh, it would be 3, right? And so we would put dot 3H2O. Okay. Suppose you heard the term octahydrate. What would you write? Well, you would go dot, and then you would write H, 8H2O. Okay, so that means whatever that chemical is, it's got 8 waters attached. Okay, now look at this. What will we name this thing? Well, as you guys know from all our time naming, that's magnesium sulfate, right? However, magnesium sulfate, it turns out, has 9 waters attached. So this would be called magnesium sulfate nonahydrate. Nonahydrate. Alright, so there you have it. And then here's one. Write a formula for calcium chloride dihydrate. Well, as you guys know, the formula for calcium chloride is that, right? We know calcium as an ion is +2, chloride as an ion is -1. Okay, and then we have to add how many waters? Well, we have to add 2 waters, right? Hopefully that makes sense. So 2 H2Os. Right? Now here's the part that's important. When we got to find the molar mass of a hydrate, it's not just the weight of magnesium sulfate. In other words, it's not just the weight of magnesium, 1 sulfur, and 4 oxygens. We also have to add these 9 waters. And what that would mean, if the mass of water is 18.01 grams per mole, so whatever the weight of magnesium sulfate is, and I don't know, 100 I don't remember what it is. Anyways, I would times this 18 by 9, and I would get a total weight. Okay, and I think I've got it written down here. 281.15 grams per mole is the weight. So the thing that's important is, however many waters, you've got to add those 18. So what's the point of this? Well, we've been messing with the empirical formula, right? And it turns out that those hydrates, those waters that are attached, attach in a mole ratio. So we've got one of these, 1 mole of, or you could, in this case, you could say 1 formula unit of lead nitrate, and 4 waters. Well, if we bring that up to amount of moles, that's the same as 1 mole of lead nitrate and 4 moles of water. So since we've been doing empirical formula, we could figure out the number of waters attached to a hydrate. So here's an example problem, and this is one that we're going to end up doing in our lab. So if you look at right here, you see you've got 35.69 grams of cobalt, 2 chloride cobalt 2 chloride hydrate was heated, after heating 19.47 grams of anhydrous cobalt chloride was left. What's the formula of the hydrate? Well, the first thing I want to do is I want to find the number of moles of my anhydrous stuff, right? So it's 19.47 grams, and it's called cobalt 2 chloride, so the formula is CoCl2. Okay. And I'm going to find moles like we've been doing many, many times. So I know that 1 mole of cobalt 2 chloride weighs 129.84 grams. And you can check with your calculator if you want to. And so what that gives me is 0.149 moles. Okay. So that's that. Now, I also need to find the moles of water. Okay, so how many grams of water did I have first? Well, I started with 35.69, heated it up, drove off the water, and I'm left with 19.47. So the difference between those two numbers must be my water. Okay, so when I subtract those two, I get 16.22 grams of water. All right, and so what I'll do is I'll just find the number of moles of water. 1 mole of water weighs 18.01 grams, and when I work that out, I get 0.901 moles. Right? Now here's an important point. Empirical formula. After you find moles, what do we always do? We divide by small, right? So the small in this case is, of course, the 0.149. So divide by 1.49. And I get 1, that probably makes sense. And then this one, 0.149, when I divide by that, I get 6. Okay? So what this tells us is that for every cobalt chloride, there are 6 moles of water. So then the question is, what is the formula of the hydrate? Well, it's CoCl2 dot, and then it's 6 waters. Okay? And it fits the mole ratio with empirical formula. So there you go. Quick, short video. Hopefully that all makes sense, and we'll see you next time.